about 88?
Sure.
How, wait, maybe that's not the, wait, what is 88? Is that
88.
the,
It
is that
says
the
the
one?
first derivative of the function f is given by f prime equals sine of x squared.
Okay. Yeah, how do you, can you do 88? Just, I was gonna ask a question, but can you just do it?
Sure. All right,
Thank
so
you.
we're given that f prime of x is sine of x squared. At which of the following values of x does f have a local minimum? All right. And so remember, this is already f prime. So we're just going to look at the graph of f prime and figure out when it changes from negative to positive. All right. And so we're just graphing this. So a couple things. We want to make sure that you are in radians. And so you go to your calculator and you graph sine of x squared. All right. And you hit graph. And obviously you see this picture, right? But now it did say, when does it have a local minimum, right? So we're looking for the graph to go from negative to positive, right? And so if we were, it doesn't give us, right? And so now we're just checking those values, right? So they're all positive. So I'm gonna zoom in, I'm gonna change my window and go from like minimum of of like negative 0.5. And then you see the largest of the values is like 2.507. So I'll make this like 3. All right. And so you'll get a little bit better of a view here. All right. So we're looking for this graph to go from negative to positive. Now, it's also kind of weird right here at 0. It's hard to view. So I'm going to change my y's to like -1 to +1 just so I can see closer to the axis. So now at 0, you very clearly see that it's above the x-axis, 0 then above. Then here, it's above then below, and then here that's below then above. So remember, we're looking for a relative or local minimum. That means the graph of the derivative changes from negative to positive. So that's right there. So that value looks like it should be 2.507, but just to verify, we find the 0, we move the cursor to the left side of that 0. So here is fine, and then move it to the right side here, and then we get 2.507. And so then it looks like the answer for 88 should be A.
Wait, so I thought local mins and maxes have to do with like when you do f double prime, right?
Now, so remember, okay, if I'm looking at a graph of f, right? So let's say this is a graph of f, okay? Okay, right here is a local maximum because f prime changes from positive to negative, right? Here, this is a local minimum because f prime changes from negative to positive, right?
Mm-hmm.
But if I'm looking at a graph of f prime, so let's say I have this, right? And if this is a graph of f prime, now a local minimum on f is going to be right here at this x value because f prime changes from negative to positive, or here because f prime changes from negative to positive.
So what was the first graph? A graph of f? Oh,
This picture was a graph of f. Now, in our problem, you were given that f prime is the sine of x squared. And so I graphed f prime, which is what we were given, right? And so this was a graph of f prime. So we were looking for where this graph goes from below the x-axis to above the x-axis.
Okay.
Okay?
Could you do 84, please?
84.
Also, the video for 78 doesn't work.
It doesn't work.
It says video unavailable. This video is a duplicate of another YouTube video.
That's weird. Let me see. I just clicked on the link. I'm just seeing what's going on with it.
Hello.
Oh, that is interesting. Yeah, I was having a lot of issues with YouTube today. So yeah, I'll replace that link in just a second. All right, so that's 78. And actually, to answer Kate's question about the video of this, I forgot to start recording it until like just a couple minutes ago. So the video of 77 won't be on there, but I can redo it, or I can show you
I don't think we even
Oh,
did
we didn't even
70.
talk about 77, did we?
No.
No.
Nobody asked about 77. So, oh yeah, typical me. All right, I'll just do 77 now then. Is that okay? And then I'll replace that link for problem 78 in just a moment. All right, but 77, let's see. Hey, actually, Mr. Davis, while I'm doing this, can you go to my YouTube channel and grab a link for that problem number 78 and replace the link and see if that'll work?
Sure, yeah, I'll try and find it.
Okay. Because I'm pretty sure I made that video public, so it should be accessible. And if not, then I guess I'll do something else.
I have several questions for a good chunk of this practice test. A couple of them I got right. There's
Okay,
some-
so just hold on a second. All right, so 77. All right, let me go back up to 77. All right, so 77, let f be a differentiable function with selected values given in the table above. What is the average rate of change of f over the closed interval 0 to 10? All right, so you have to remember average rate of change, all right, is just the slope of the secant line, right? So m secant, right? So that's just going to be like f of b minus f of a over b minus a, right? And so f of b minus f of a over b minus a. And so all we're doing is just trying to find the f of b. So we're going from 0 to 10, right? And so f of 10, which is negative 20, minus f of 0, which is 5, over negative 20, no, sorry, 10 minus 0, right? So negative 20. So we get negative 20 minus 5, negative 25 over 10, right? So negative 2.5 or negative 5 halves, right? So it looks like number 77 should be B. Is that okay?
Could we do 85, please?
85. There is a video for that. Was the video not working? Or do you want extra explanation?
That's good. Never mind. You can go on.
Okay. Well, I mean, I'm happy to do it, but
Yeah, I'd like to understand what 85 is because like this one had my head spinning.
did you view the video?
No.
So I did create a video for 85, and it's in that document, that answer document.
All right.
Okay.
That's like one of the questions. I'm just gonna go look. 82 and 83 are like two problems that I just kind of looked at and like is.
I just did 83. And 82 has a video as well.
All right, and then can we do 84?
84, sure. All right, so let me pull up 84. All right, the function f is continuous on the closed interval 1 to 7. If the integral from 1 to 7 of f of x dx is 42, and the integral from 7 to 3 of f of x dx is negative 32, what is the integral from 1 to 3 of 2f of x dx? All right. All right, so what we look at here, all right, is I'm given 1 to 7 and then 7 to 3, right? Now, it's actually helpful that they gave this one as the integral from 7 to 3, because if I were to take the integral from 1 to 7 of f of x dx and add it to the integral from 7 to 3 of f of x dx, right? Remember, when we're adding these two integrals together, provided that their integrand is the same, which they are, then the 7's, which are on the diagonal the same, that means we can combine those and give us the integral from 1 to 3 of f of x dx. And so now I'm looking for the integral from 1 to 3 of 2f of x, but remember, we can just bring this 2 out front, right? And so really, we're looking for 2 times the integral from 1 to 3 of f of x dx. And so now I just need to figure out what the integral from 1 to 3 is based upon this equation. So now the integral from 1 to 7 was 42, plus the integral from 7 to 3 is negative 32. And so it looks like this value is actually just 10. So we're looking for twice that, right? So it looks like our answer should be 20.
Can you do 89 next?
Sure. Any follow-ups with 84?
No, that's
No.
good. Thank you.
I kind of wanted to take a look at 80, but I don't know if you've done it already.
Which one?
Number 80.
80?
That one's an interesting one.
80 also has a video as well.
All right.
So that's posted in the, do you know where that answer document is?
I know where that is.
In the Schoology, if you go into the Schoology page, you know, the e-learning folder for today, you'll see it says AP Calculus AB Practice Test 1 Part B answers, and then there's links to videos for a number of selected problems.
It seems like some of the problems I actually tried answering, or I thought I had the right answer or wrong, and the problems I skipped have video links. So that's kind of I need to figure out how to do all this work.
Okay.
But go on.
All right. So what was the next question that
89.
89. Okay. All right. Problem 89. All right. So
Can you just explain it? I mean, it's mostly just words, but
yeah, there's really not some work to do there. Okay. So it says if the limit as x approaches a of f of x equals f of a, then which of the following statements about f must be true? All right. So that statement, I am going to write it down. The limit as x approaches a of f of x is equal to f of a. This is the definition of continuity. So remember, when we said a function was continuous, was if at x equals a, right? So at x equals a, if f of a exists and is equal to the limit as x approaches a of f of x, then we can say f is continuous at x equals a, right? And so that's what we are told specifically by that statement, right? So which of the following must be true? A, f must be continuous, all right? But what about B? F is differentiable. Well, remember, just because you're told something is continuous doesn't mean that it is necessarily differentiable, right? It could be like a corner point, cusp, vertical tangent, something like that. All right, so A is not necessarily, or sorry, B is not necessarily true, all right? And then if we continue on and we look at C, for all values of x, f of x equals f of a, well, no, all we're told is at x equals a, right? So it doesn't mean that every other point has to be the same as f of a. D, the line y equals f of a is tangent to the graph of f at x equals a. That is not necessarily true, all right? Because then that would indicate that it was a horizontal line. Y equals f of a would have to be a horizontal line. And you're not told that the derivative even exists there. And then y equal, the line x equals a is a vertical asymptote of the graph. That would definitely not be true because that would mean that the limit would not exist there. Okay, that's 89.
Can you do 91, please?
Okay. All right, moving on to 91.
90 as well.
All right, number 90. Did you say, David?
Yeah, number 90.
Yeah, there's a video for number 90 as well. So before you leave on here today, I want to make sure that you know where that document is so that you can access all those videos, okay? 91. All right, if f prime of x equals cosine of x squared. And f of 3 equals 7, then find f of 2. All right, and so we are given f prime, all right, and we're given f of 3 equals 7, and we want to find f of 2. So basically what we're going to do is, this is like a section 9.2 question, where we're going to integrate f prime of x from 2 to 3, because that is going to equal f of 3 minus f of 2. And so we are trying to solve for f of 2. So we're going to add f of 2 over, and then we're going to subtract the integral. And so we're going to get that f of 2 is going to be equal to f of 3 minus the integral from 2 to 3 of f prime of x dx.
Hold on. All
And
right,
so f of 2, we want to know. F of 3, we are given as 7 minus that integral is what we need to calculate. So we're going to go ahead and calculate that. All right, so I'm going to go to my calculate screen, math 9. So I'm going to integrate, what is the function? Cosine of x squared. So cosine of x squared, comma x, comma 2, comma 3. All right, and then make sure you're in radians. And so I calculate and I get 0.241. So 7 minus 0.241. And so 7 minus 0.241. All right, and we're going to get 6.759.
759, which is D.
All right,
Thank
and so 91 should be D.
Yes. I
Okay.
forgot about.
Wait, I have a question.
Yeah.
There's no way if we were just supposed to integrate the cosine x squared thing, there's no way that we'd be able to like do that as just an indefinite integral, right?
Correct.
Okay.
Yeah, because you'd have, if it was like x cosine of x squared, right, then you would be able to, but this is one that is definitely a calculator question. You know, and when you look at the answers, when you see all the decimals, like that should be a hint that you're gonna have to type something in on your calculator.
I completely did this problem like a Unit 6 problem because I integrated the problem, got u plus c, and then I had to figure out what c.
Oh, yeah. So you cannot integrate this by hand because it would require a u substitution of x squared, and if you do that, you don't have an x on the outside. So that should be a red flag that you cannot approach it as a Unit 6 question. Okay, so hey, David, real quick, I want to show you the document that I'm referring to, okay?
I know what it looks like.
Did you find it?
Yeah, I found it.
Okay. All right, other questions that that we didn't do or that you came in late and you missed and you want me to do again, or
76, I came in late for 76.
76?
I was-
Yeah, so 76, I'm just going to reshare what I wrote earlier and I can describe it. So 76 right here, you're given P of T, which is in billions of people. And so if you were thinking about a graph of P of T, it would be P of T and T, all right? And so if you had billions of people and you were looking for the slope here, that would be like the rise over the run or the Y value divided by the X value. So billions of people divided by years. So billions of people per year is the unit that you're talking about. All right, and then it says that the years are since January 1st, 2010. So when you look at the answers, you see, if I go back to that answer, all right, so choice B says on January 1st, 2011. So that would be 1 year since January 1st, 2010. The population of the world was increasing at a rate of 0.076 billions of people per year. So C is wrong because that is just talking about P of 1, not P prime of 1. And A would be wrong because that would only be 1 month since January 1st, 2010. So that would be the common mistake with that one.
I thought B was potentially the right. I thought D and B were potentially the right answer, but I think the reason why I chose D was because I thought that in the context of this problem, I thought it was talking about like how many the average rate of change of people in 1 year in between the closed interval 0 to 1 year.
Oh, so you got to remember that like the derivative is the instantaneous rate of change. So it's not average rate of change.
So that's what P prime of 1 represents, the instantaneous rate of change, not
Yes.
the average rate of change. So that's why B was wrong because
Yep. All right. Anything else?
other problem solving. 87 unless it has the video 87 or 88 unless they have videos.
87 or 88. I think there's okay, neither of those. Let's see, did I talk about 87 or 88? I did talk about 88. So if you can see this one, 88 here. All right, so we're given a graph of f prime, or we're given an equation of f prime, and so we want to graph that on our calculator. All right, and when we graph that, all right, we get a graph that, well, what does it look like? Do I still have that over here? Sine of x squared, right? And so if I hit graph, this is the graph that we get, and I just kind of changed the window a little bit to make it easier to view based upon the answers. But we're looking for where f would have a local minimum, and remember, a local minimum occurs when f prime changes from negative to positive. So we're looking at this point right here because that's where this graph changes from negative to positive.
So
Okay.
I was confused because if this was f prime, was I supposed to was I supposed to put this back into f of x so I can
No.
put it in the calculator?
You do not need to get f. You're just looking at the graph. So you really want to like cut down on trying to do extra work. So when you are looking for a local minimum of f, you're just going to figure out when f prime changes from negative to positive. You don't actually need to get f.
Can I take a look at those two graphs, because I think that might be helpful in explaining what the right answer is.
These two?
Yeah.
So these are just sketches. These aren't what this graph actually looks like. This is just something that I drew to think about like local mins and maxes.
Mm-hmm.
This is not like a specific graph for that particular problem.
Right. So I'm still trying to figure out like what all this means, because I'm still like I'm like puzzled.
Okay. Brenna is still here. Brenna, do you have additional questions? You go ahead and unmute yourself.
Oh no, I'm fine.
Okay.
Sorry, I didn't realize that we were ending.
Oh, no, we're not ending necessarily. I mean, if you have more questions.
No, the only question I had was on 88, but you answered it.
Oh, okay. Yeah, I think this was a little shorter, and because we already had some of those other videos, there weren't as many questions as the other day. So
Yeah, because most of the questions I got wrong have videos for them. So
yeah, Mr. Davis and I tried to figure out which ones were the most likely. And it's always nice when people can access them whenever they want.
yeah. Okay, well, thank you.
Yeah, of course.
Hi, Brenna. Mr. Bonrigo, I did fix that one link. That was for 78, right?
I believe so.
Yeah, 70. I thought you had said 77, but there was no video for that.
Oh, yeah. No, it must have been 78.
Yeah.
Yeah, because I clicked on it as well, and it gave an error.
Yeah, same.
It was part of all the issues I was having uploading this morning. It was like unbelievable how long it was taking to save to Google Drive. I think it was a Screencastify issue, but I don't really know. So I at first, when things weren't uploading, I was just using the like the Google Drive link, and then once they finally uploaded, then I pushed them over to YouTube, and then I updated the links. But I don't know. Seems okay now.
The publish straight to YouTube feature.
I'm not sure. Like it doesn't have to save to Google Drive?
No.
So is that in your settings or something?
I don't know. It just showed up as a button last time I used it.
No, I mean I can publish from the Screencastify link, but
I mean it might. I think it still saves to your Google Drive.
Yeah.
I don't really care if it's saved to my Google Drive if I have it on YouTube.
No, but it wouldn't let me publish to YouTube until it's saved in my Google Drive.
Gotcha. So maybe that was what was slowing it down then.
Yeah, because I didn't think I use that publish to YouTube button, but I just didn't realize, like, I didn't think you could do it until the video actually saves.
I guess. I guess the
Yeah,
only.
because when it says where would we save your videos in like options, it's either Google Drive or on my local device.
Yeah.
Yeah. Okay. All
I
right.
guess the other questions I have up my work is numbers 83 because I got stuck with
83.
1 and 87 because those are the.
Okay, so 83. So I got the work right here. You're given this dx dt. So that's like the velocity already. And
Yeah,
so
that's-
then you're just going to take the derivative of that velocity to get acceleration. And so
Yeah.
when you take that derivative, you get negative 40t cubed plus 18t plus 8.
Yes.
And then you're going to set that equal to 0 because the question says, when is the acceleration equal to 0? So then you're going to use your calculator and solve that, right? And so you're going to go here and you're going to go to y equals, and you're going to type in that negative 40x cubed
Oh, do I plug this?
plus
I
8x plus 8.
I thought I just made 0 equal to the function. That's what I did. That's what I was trying to do, and that's how I got stuck. Is wait. am
Yeah,
I-
that's just when the velocity equals 0, but it says when is the acceleration equal to 0.
So hold on. I'm just gonna no because I tried to say if a is equal to 0, then well, what happens if we have the negative 40t square cubed plus 18t plus 8 equal to 0? Would that be my answer or no?
Well, yeah, so then you just want to use your calculator to solve that. So I graphed it here, and then you see it crosses the x-axis there. So I use the 0 function and make sure just to move the cursor to the left side and then to the right side, and then you get 0.831.
So hold on. So basically, just figure out where the x-interception is,
Yeah,
and then
of the acceleration.
so you can trace. So intersection at. God, I can't tell where am I. Oh, here we go. First curve. I guess right here. Second curve.
All right. Anything else?
I'm still trying to wait. Let me see if I can get y of equals 0 in there. Is that?
What do you mean y equals 0?
Do I put y equals 0 in my calculator?
No, you have to use second trace.
Yep.
And then
Second
go
trace
to
and then
0.
oh 0. I pushed intersection. I
Okay.
don't know why I did that. Second trace 0 and then okay. And then a is equal to 0.831. 831, that should be the answer, which it is.
Yeah.
If I can go through the answer sheet. 83B. All right. And then 87 is the other problem. And I think the rest of the problems that I had questions for, or any other problem that I tried to correct, but it's actually wrong. Any problems that I skipped or any problems I need to correct are all videos. So
Yep.
I guess I'll do those. Number 87.
87?
Yes.
That never came up, huh?
Did we cover 87? Did you guys cover 87 before I got here?
It didn't show up on one of my sheets.
Alrighty, then I guess we'll do 87.
Okay. All right. So 87, if you're looking at that. All right. The graph of the piecewise linear function f is shown above. Let h be the function given by h of x equals the integral from -1 to x of f of t dt. All right. On which of the following intervals is h increasing? So h is increasing when h prime of x is positive, right? So we're given h of x, so we want to find h prime. So how do we find h prime? When a function is given by this, according to the second fundamental theorem of calculus, we are going to plug x in for t and multiply by the derivative of x. So f of x times the derivative of x, which is 1. So h prime is actually just f. So when we are told that this is a graph of f, then this is really just a graph of h prime. So it says, on which of the following intervals is h increasing? Well, that would mean when h is positive, h prime is positive, which means when it is f positive. So when is this graph above the x-axis? And that would be from 3 to 9.
So, which is, let me go back to my answer sheet.
Like choice E.
E. Oh, that is E. I already had it written down. Let's see, any other, I guess, yeah. Let me see if I can look for other problems. Sorry, explain 76, 77 is correct. 70, I guess 78, 80, 82, 85, 88. No, we already covered 88.
90 and 92.
92 are the videos. And
Yep.
I guess my work here is done. Thank you for assisting me with these
Of course.
problems. I guess these, I guess even if I do poorly on these practice tests, if I do well on these corrections, then I should be able to at least fix my grade.
Yeah, don't worry as much about your grade as just, continuing to, try to understand the problems that we're going over. And, I would say focus less on the grade and focus more on just, making a good attempt and asking questions when you don't understand or viewing videos that we put out and things like that. Okay?
Yes, at least the majority, at least I had a small handful of problems that I did the work for and got correctly, which I'm kind of happy.
Yep.
Anyways, hope you two have a nice weekend. Stay safe. And
Okay, you too.